true. So, all right, probability. Fancy way of saying here at the start, the fundamental counting principle. Sounds so big and important, and it's not too bad at all. So,
I thought you were going to say it wasn't important.
no, that's not what I was going to say. So, when we're doing these, okay, we need to know the total number of possible outcomes for something, or when we're trying to determine that. So again, it can be anything from words, where we're trying to figure out, how many different options there are, whether I've got like letters of a certain word and I want to know how many different words can I form, or symbols, or like I was talking to you before we started recording this, figuring out how many different possible combinations there are in the pick one things at Applebee's or Chili's or Fridays or any of those places. So when we're looking at it in its most basic form, for instance here, with our example 1, if there's 4 possible blood types and 2 possible Rh factors, there are 8 possible ways to label the blood donations. In other words, when you're using the fundamental counting principle, you take each of the types of things, so like if I was doing my blood types,
Multiply them all together.
yeah, you're just basically multiplying how many options there are in each, and it tells you the total number of outcomes, or the total number of possibilities. Okay? So you're like, oh, this isn't going to be bad. And it's not, especially here at the start with these. Again, example 2. Bicycle manufacturer makes 5 and 10 speed bikes in 7 different colors, 4 different frame sizes. Now here's the part people forget about though. They'll multiply 7 times 4 and say 28.
Yes.
But
No.
colors and frames would be 7 and 4, but watch the very first part. 5 and 10 speed, there's 2 different speed types. That's the type of stuff you've got to be careful of on these. Speed type times color times frame would give you 56 different types. So you still have to read carefully, even though exactly what I just did is down here below. Okay? But sometimes there won't be a direct number. They might talk about body types if you're talking about cars, or here, speed types if you're talking about bikes. So don't get sucked into forgetting about that. You're like, dang, Hardy, we've never flown through notes this fast ever. Now, just because this is a little bit easier doesn't mean you can go completely like brain dead on this for the next whatever, because it'll be that one moment that you kind of relax that'll be like, I'm screwed. So, when we're working on these, the first one we're going to talk about, there's permutations and there's combinations. We're going to talk about permutations first. These are the ones where order is going to matter. Okay? So like if you're picking who's going to be the president, who's going to be the vice president, that matters. But if you're just putting books on a shelf, it may not matter quite as much. Okay? So, for instance, when we get down here, okay, again, it talks about certain orders in objects. So, I look at these, and I'm like, okay, so what's it talking about? For example, there's 6 permutations of the letters A, B, and C. When I flip them around, it matters, A, B, and C is different from A, C, B, or B, A, C, or B, C, A, or any of these. But what you're asking yourself is, and I guess I'll kind of try to simplify it on the screen here. So for instance, in this case, once I choose a letter, I cannot use it again so I lose one option. That's kind of how any permutation would work. So like for instance here, if I choose the first letter, when I'm choosing the first letter of my 3-letter combo, I can use A, B, or C. I have 3 choices. But once I pick one of those letters, if I choose A for the first one, now I've only got 2 options left for the next letter, B or C. So that's where the 2 comes from. I lose a choice. And then I choose that last one, then I choose B for the next one. Well, now I only have 1 choice left for the 3rd letter, whichever one's left. I'm still always multiplying, though, with those. So there's 6 possible combinations. And if you had a lot of letters, you wouldn't want to sit there and have to write every single one out. that would be a pain. So it just gives us an idea. So of course there always has to be a funky way of doing this. Math can't keep it just simple like that. So there's this thing called factorial. Okay? When you multiply products that keep going down by 1 each time, factorial is written as an exclamation point. The exclamation point means you start at that number and you multiply every number set below it. So like if I had 5 factorial, it would be, in reality, 5 times 4 times 3 times 2 times 1. It just goes all the way down, but it's just a shorter way of writing that out. And it's done down here below in kind of a weird, complex-looking way. Okay. N factorial, you just start with that, and you just keep subtracting 1, and then 2, and then 3, and so on. Okay. But 0 factorial will always be 1, just like, you know, anything to the 0 power equals 1. So when you're doing a factorial, practice, best way to do things. 4 factorial just means I start at 4, and I multiply down. And of course, I still need to multiply this out. 24. And yes, there will be a way as we start working with these to shorten things some. This won't get to a point where you're doing like 20 factorial and you're going to have to multiply every single one of those. But it's just kind of understanding how it works. So 7 factorial, I just start at 7 and multiply my way all the way down. Okay, 5,040. And so as you're doing any of these, just start with the biggest number and just keep counting down by 1 each time. Okay, so the concept of factorial isn't going to be any. 0 factorial would be 1. Because the last number that you always use is 1, so if it's 0 factorial, I have no other numbers to use except just the 1 itself. So, where does this kind of come into play? Well, if we move up here a little bit, okay, there are 8 finalists in a band competition. How many different ways can the bands be ranked if they cannot receive the same ranking? If I was doing them individually, I'd sit there and I'd say, well, you know, when I'm looking at first place, there'd be 8 choices, but then one of the bands gets first. So then the next band that gets second place there'd be 7 choices. And 6, and you're like, oh, I see where this factorial thing is coming from. Basically, what's going on is I'm just going to keep multiplying. Oops. And I'm kind of oversimplifying here a bit, probably to some of you, but it's just so you can visually see. And the poor band that finishes 8th. But if you did it individually, the fundamental counting principle would say I have 8 choices, 7, 6. But 8 factorial is a faster way of writing that. So I'd still have to multiply that out. So there's actually like 40,000 plus different ways that these bands could finish in order. So for any of you that have ever been curious on really how crazy your odds are of winning the lottery, you sort of can start to figure that out now. I mean, I don't even remember how many balls there even are anymore, but let's say there were 60, and you had to get 6 numbers right. It'd be 60 times 59 times 58 times 57 times 56 times 55. Yeah, that's going to be a really big number.
Didn't one win from Freeport? I heard on the radio this other one.
I don't know.
I went there and about a lot of games.
Well, okay. Now,
They say you got a better
here's what we're going to do. Since this kind of goes quick, I'm going to keep going in the notes, because that way I can actually get you into where tomorrow is just a work day, and there's going to be nothing note-wise. So, huh? I didn't say that. So, now, flip over with me. All right. Now, we're going to step up a little bit here. Not much, just a little bit. They're like, oh. All right. So permutations of n objects taken r at a time. In other words, we're going to have a couple of different things going on here. So, for instance, okay, suppose in that last example with our bands, we wanted to know how many different ways the first, second, and third place rankings could be awarded. We don't care about like 4 through 8. We just want to figure out how many options there are for those first 3 places. It's the same idea, except now, since I'm only looking for first, second, and third, I'd still have 8 choices for first. I'd still have 7 choices for second and 6 for third, but that's all I want. Is there a way to use factorial for that as well? And there is. There's actually going to be a formula we're going to introduce you to. So how would I figure that out if I didn't just do 8 times 7 times 6? Which, by the way, is the way I would suggest you do it anyway. But I was asked by the probability and statistics teachers to also show this because this would be part of what they're introducing. So, for instance, I can use factorials. 8 factorial would tell me how everybody could finish, like we did in example 2. But if I only want to know the top 3, you take your total number of options minus the number that you want. I only want to know 3 places. So 8 minus 3 would get me to 5 factorial. So you do 8 factorial over 5. Well, I don't want to write, calculate all this. So I wrote it out, but watch what you do. You just take the numbers that are identical and cross them out, and you see where this came from. Now again, common sense to me is, if I only want to know first, second, and third place, I'm just going to do 8 times 7 times 6. I'm not going to necessarily write all of this out. And I don't care which way you do it. I'm just kind of showing you an option, because sometimes that may help to be able to have the formula instead of trying to think about it this way. So look at this fancy formula we get. The number of permutations of our objects taken from a group of n distinct objects is given by. You may see something, especially on a standardized test, that may be written in this form. And what that simply means is, for instance, in example 3C, how many different ways can 2 students be assigned to 5 tutors if only 1 student is assigned to each? Now this is just me. I'm sitting here going, well, I've got student 1 and I've got student 2. Well, if there's 5 tutors, I have 5 choices for student 1, but then I use up one of my tutors. So there's only 4 choices for student 2. I multiply them and I'm done. Now, could I do that with a factorial? Sure. Well, yeah, and some of you, we got the button on the calculator to play with. And I'll show you how that works too as we start to get into this a little bit further. But for instance, here I could say, okay, 5 factorial is the total number of options, but I only want it for 2 options, so I'd subtract 2 from that. And then just like before, my extra ones cancel. Now, it was interesting, Chris just made a good point. He goes, you can do this on the calculator, and that's true. I can do permutations and combinations right on the calculator as long as I know which one it is I'm on the lookout for. So if I wanted to do this particular one, here's how this would work. You type in your first number. Okay, so in this case, that's the 5. Then you're going to hit math. So here I'm going to put, I'll kind of write the steps here. So first number, that guy. Okay. Then we're going to hit the math key, and you're going to work your way over to probability. And in this case, I want permutations, because NPR stands for permutations. When we get to it, NCR is going to stand for combinations when order doesn't matter. So I can hit 2, because that's going to be my permutations. So this NPR shows up. I was going to say, even a lot of the basic scientifics will have it somewhere. You might have a factorial, so we may be able to find that. And then you type in your second number, which in this case is 2.
So,
hit enter.
that's 700. I got 20.
You get 20. Okay? So you can do it on the calculator, but again, most of the numbers we're working with are going to be small enough that you're really going to just probably just do it in your head or do it quickly on your own. But that's an option for you. Okay? So maybe we'll start playing with this a little bit more. And shock of shocks, people, we're almost done with the whole note packet already.
You're so nice when you guys
I try. So, all right. Here's our other type. And then I will be done. Okay? Combinations. Big point to notice here. Order is not important. So for instance, I select 3 out of 4 books for a book report, okay? If I read, I'm trying to think of some books off the top of my head that you read in like English, okay?
What?
So you come up with 3 books. The order that you read them in isn't going to be important if you're having to do a report on all 3 anyway. So selecting books A, B, and C is not any different from C, B, and A. So if I give you a quarter, a dime, and a nickel, it doesn't matter if I give you a quarter, dime, and a nickel, dime, and a quarter, a quarter, and a nickel. It's all the same thing. So if I'm wanting a combination, you're going to notice there's something a little bit different. Because when I'm doing a permutation, it was just n factorial over n minus r factorial. But now there's another piece that comes into this. Because now that I can move them in any way I want, that's going to change things up a little. You notice there's one more part to this. So this is where it gets a little more complex. So, how many ways are there to choose 5 cards from a standard deck of 52? Since the order in which the cards are chosen is not important, the situation involves combinations. Now, you don't want to have to write all of this out. Now, some of you may say, well, wait a minute, if I'm just choosing 5 cards, as I pick each one out, doesn't that basically just mean, you know, first card I have 52 options, then the next one I have 51, the next one I have 50, and then I have 49, and then I have 48. Ooh, that number's not the same. Right, because the whole idea that the order doesn't matter is going to change things up some. So, here's where knowing that little formula is going to come in handy. 52 choices, okay, when I start. I'm going to choose 5. So I do the minus 5, but then I also use that 5 as a factorial out here. But here's a quick way for you to remember how this works. What's 47 plus 5?
A lot, big number.
52.
Yeah.
These 2 factorial numbers always would add up, just the plain number part, to whatever's up top. So like if you had something, for instance, like the combination of 10 choose 8, it would be 10 factorial over 10 minus 8, which is 2 factorial, 8 factorial. These 2 numbers always add up to the number on top. But if you don't want to have to write all this out, for instance, because you're like, so I'd have to write out 52, 51, 50, 49, 48, 47, 46. No. Okay? If I didn't have a fancy calculator way of doing it, check this out. I'm going to start at 52. I'm going to write numbers until I hit that first big factorial number. 47. Stop.
Oh, wait, what? Oh, okay.
Down here, I'm going to leave the 47. And then 5 factorials, 5 times 4 times 3 times 2 times 1. Here's why I'm doing it this way, if I don't have a fancy way of doing it on a calculator. The 47 factorials will cancel. You're like, yeah, but I still got all this left. You have 2 options. You can either type this part in, hit enter, and then divide it by this, okay? That would be an option. So I could sit and I could say, okay, I'll deal with
Or
this.
you can start reducing.
Exactly, and I'm going to talk about that in just a second. So 52, 51, 50, 49, 48. Whoops, not 49, 49, 49, 48. You're like, oh, well, there's that big number that I had before when I just did that. Hardy, why didn't you just look up there? Well, because I'm dingy this time. So 311875200. And then I'm going to divide that by, let's see, 20, 60, 120.
Yeah, I do that back in my.
In your head, yes. In your sleep. All right. So I find out there's still an awful lot of possibilities here. Okay. But as Ben had mentioned, I could, if I didn't want to deal with as big of numbers, let's say, I would have the option, like for instance, I know 5 goes into 50. Okay, I could put 5 into 50 and reduce it down. Or 4 goes into 48. I could reduce that down. For some of you, seeing all those other numbers and canceled and what do I multiply is just going to confuse you more. But for some of you, that might be something that's good. For instance, I'll kind of show it off here to the side. I'll do it instead of doing it right on here. If I took that exact same problem that I have here right now, and I said, okay, all right, so I already canceled these. I know 5 goes into 50 10 times. I know 4 goes into 48 12 times. 3 goes into 12 4 times. And 2 goes into 4 twice. Now, instead, I've wiped all of these out. So all I would have to do now, if I wanted to do it that way, 52 times 51, exactly, times 10. Well, and I think a lot of you are going to feel that way. And that's why I'm kind of like, you know, do it either way. I like to show options. For on smaller numbers, it might go faster, especially if it's something you're just thinking about quick. But either one of those will work. And of course, the fastest way of all, if you're playing with one of the calculators in here, would be if I know what the combination's going to be, type in the first number, 52, go to my math. Now I want a combination, so I'm going to do number 3. Type in my 5. That's really fast. So, again, you've got options, but it's not going to be that big of a thing. And finally, is it going to happen? There's actually going to be work time in a day, but there's going to be work time the next day. Amazing.
Amazing.
All right. First one. 25 students write their names on a slip of paper. 3 different names are chosen at random to receive prizes. Determine whether each situation involves permutations, order matters, or combinations. Order, who cares? Choosing 3 people to receive a no homework coupon.
Wait, what?
Does the order matter if I'm picking 3 people to each get a no homework coupon? No, because they're all getting the same thing. Order, who cares? Order matters. So, they're all getting the same thing, so it doesn't matter what order I pick them in. The first person and the third person are both getting the same thing. But now if I have 3 people, first prize gets a graphing calculator, second prize gets a no homework coupon, and third prize gets a pencil. Okay, that matters. That's a permutation.
I'll do that one instead. I'm going to take the graphic.
So, here's your job for now. There's 2 different assignments written in this note packet. You are not responsible for the one that is currently on the screen yet, but if you want to get ahead, you can do that. The one you are responsible for going into tomorrow is this one, the one on page 705, the back of the first page. I have a plan already. Okay, tomorrow we'll go over answers to this. This one will get assigned tomorrow along with a worksheet. And then when we get to Monday, and I'll tell you right now, you will be done with all 3 of these by the time you leave tomorrow. I'm telling you right now. You will go into the weekend with no homework if you work at all in class.
So I was like,
All tomorrow.
do this tomorrow.
So,
Does that mean I can't for
whatever. No.
Okay.
My plan is, once I stop this,